Understanding data warehousing is key for every data professional. Let's make it crystal clear. Imagine a customer moving from Hyderabad to Bangalore and then to Mumbai. How do we track these changes? That's where slowly changing dimension come in. In this session, we will cover the foundations, data warehousing basics, keys like candidate, primary, foreign and surrogate key, and how fact and dimension tables fit together. Then we'll dive deep into all 6 types of slowly changing dimensions, from type 1 where data are going to overreturn to type 6, the hybrid approach that combines best of everything. Each explained with theory, real-world examples and SQL implementation. By the end, you will move from confusion to clarity and gain confidence to design and manage real-world data warehouses. So what you are waiting for? Watch the full video now, subscribe to the channel and let's grow together in the world of data engineering.
So first of all, let us just have a quick look at what we are going to see in this lecture actually. Okay, so we are going to see very importantly the first one. We are going to see the prerequisite part. So that is what is simply a data warehousing. Different keys will be there in the DBMS because that is really matter to understand the concept actually. And at the same time, dimension and fact tables, without these words, there is no database in real world actually. So that's why we should have a good command on all these things actually before going to deep dive in the SCDs part. And not only this, in many other places also, all these prerequisites are going to play a key role. So anyhow, we are learning here, so that is the good thing. So now, if you see the next one, very importantly, we are going to, of course, we will see the SCD introduction and different types are there. As we are seeing here, there are total 6 types. So that's what different SCDs. And then if you see the next one, use cases in each SCD, where you can use it, how you can use it. So you are going to get a good direction so that betterly we can apply in the real world actually. And then the next one is lab. So after each SCD understanding its core concept, we need to implement that somewhere actually. So we can implement in SQL as we are going to see in the discussion, and we can implement even in the PySpark, even in advanced tools like Data Factory. So anywhere in the Synapse. So in many places we can implement the same concept, and then we are going to see the best practices. So this is what actually how you can apply. And when so many times you have a trade-off kind of situation, like if you are basing on the data you have, which SCD you need to apply. So that's what different situations will be there. So what decision you need to take actually on that particular data to implement, which type of SCD we need to implement. So that's what overall we are going to see. This is just for namesake what we are seeing here, and many more things, much more deep dive discussion is there in the overall lecture. So let us get started. Then now, very importantly, nothing is there overally in the whole concept. Let us slowly, in the medium phase, let us try to understand that these concepts are all prerequisites are there, or whatever SCDs are there. Let us try to understand very clearly what is data warehouse. So this is in the data domain, everyone should aware first of all at the basic level. So simply what you can say, it's a central repository where you are going to have a data actually. Okay, so this data in general you are using for analysis and for reporting. But before that, to do analysis, to make the reports on top of this data, that data should be very organized manner, very in a well structured manner. That is really matter actually. Okay, so for example, let us take a simple real world example. Suppose here if you see there is a picture. In that picture you have the books. So all these books is not organized manner actually. So you see here these books simply kept one by one actually, just like a stack they kept it. When the problem will come, Suppose if you want to identify so and so book from this actually, that is not at all easy to identify actually, is it? So what we need to do overallly, you need to go one by one actually. Each book you need to search for your required book actually. So just throwing the items is always easy, but when you need it, it is not at all easy to get it actually. So that's what very important thing here. Suppose the same thing if you kept the books in an organized manner. So for example, if it is a library, instead of like this, you kept the department wise, suppose computer science books in this column, or for example, AI related books here, or EC related books here. So category wise columns you maintain, and in each category also subject wise different author books you maintain, so that if I need so and so book, suppose if I need data structures and algorithms book, I will come to CSE column and then I will go to the DSA category of key DSA cell, identify the author easily, then I can get back it actually. So this is well structured is really matter. That's what simply the warehouse always. Warehouse is simply, database is different, we can say simply warehouse is different. So in the warehouse, it is always well structured. Now this warehouse is for whom? For the data simply actually. So that means what? Your data kept in a well organized manner. Cleansed data, ready to use data is going to be there in your database. That database you are calling as a data warehouse. So wherever this data may be there, this data may be in the data lake, this data may be in a API, this data may be in a database also. So that particular store you can call as a data warehouse. So that's what simply you need to understand at the starting itself, what is the data warehouse. So on top of this, how this is really possible, data warehouse, when you well structured ready-made data is there to use, how this is possible. So there is some concepts are there. That is what you are going to maintain the data in fact tables, in the dimension tables. So this is on this also we are going to have a very elaborated discussion. So let it be actually. So this is possible because of this actually, and many other things are there. Let us try to understand. Okay. As we told that data warehouse understanding definition wise is very important, as we seen just now. And then another prerequisite to see SCDs clearly, the keys actually. So we are going to have a candidate key, primary key, foreign key, and surrogate key. So let us try to master all these keys one by one. So the very first one is candidate key. So what is this candidate key? Instead of going directly to the definition, I want to understand first of all from the example. Let us try to understand. So let us take this particular EMP table which we have. Let us come here. What is the candidate key first of all? So what is its definition? So it is very straightforward. Nothing is there. So uniqueness and not null actually. So what does it mean? With a simple example, try to understand here. So if you take a employee ID column, okay. So in the organization, okay, no two employees going to have a same ID actually. So this ID never going to repeat actually. This is Ram's ID. So this 101 not going to give to any other employee actually. So this is always unique. So that this column is always going to follow uniqueness. And not null, what does it mean? So if any employee joined in this company, so Ravi joined in this company. So without any employee ID, there is no employee in the organization. So that means this is never be empty actually. That means never be null value. That means it's a not null. So this employee ID is always not null and unique. That's what you can give guaranteely. So that is what simple discussion. So under this column, always the values are unique. One value you entered means that is never going to repeat. And everyone going to have some value. That is what unique and not null followed by EMP ID. Simple. Now come to the other column actually. Like in every country, every individual going to identify with some unique number. That's what. So like in US, it is a SSN. So here it is a Aadhaar. Now if you see here also, every Aadhaar number is unique. For every person, a unique number will be there. And there is no person in India who don't have Aadhaar number. So that means what? Even this column is going to follow same thing. So likewise, if you come to the employee ID, so definitely it is unique. First of all, another person trying to create same ID, that itself will not allow actually. So that's what. Then definitely everyone should provide their email ID. That's what your organization rule. Then name, it need not be unique actually. Right? Same, another person may have same name as Ram. So names may be repeated actually. So you cannot tell this under this column every value is unique. But everyone should have some name. That is something. And it is not following uniqueness, but everyone, suppose employee joined just now. So he just employee joined, but department is not yet allocated. So assume that there is a situation like that. So that means not null is null values may be possible. Then if you are taking only the persons who have the passport, only those individuals you are taking into your organization as an employee. That means what? Every employee going to have unique passport ID, and at the same time it is not null. Everyone should have actually, that is mandatory for this company. So even when you come to driving license, it is following uniqueness, but some people may not know the driving actually. So they may not have the driving license. So that is not null is not following. So some people, so Ravi don't know driving, he have a null value. That is what column wise if you observe, unique individually, not null individually. Then when it is going to become candidate key, so very simple, which column is following both unique and not null. So this is following, this is following, this is following, and this is following. So we are not considering this, but if you take this, of course, simply whoever following that will be the unique not null is the candidate key simply. So that is what here it is telling. From this table, who will become the candidates? So employee ID, Aadhaar, passport, of course, email ID also. So that is what, or for example, sometimes the employee just now joined. Suppose he is a layman, he don't have employee ID, mail ID. So that time not null you can exclude actually. So that is why you can relax it that, but guaranteely these things will be there. So that is what simple discussion about the candidate keys. So candidate key is simply a unique and not null actually. That's all. Now if you go to the next, that is primary key. So primary key is very simple really. This is from candidate keys discussion only. So simple, one of the candidate key is going to become primary key. So take a simple example that suppose there is a contest. So just like a elections actually. So to contest in that election, you put some criteria. Whoever satisfied that criteria, you are allowing them as a candidates. These are all the contestants to become a primary key actually. Only one person will win the election. That's all, simple discussion. Even here also, every table going to have only one primary key, not more than that. So, one of the candidate key, first of all, you should satisfy some eligibility. That is what unique and not null. And then, one of them you are going to select. But in our case, whichever is flexible, even in the election also, majority people selecting one person means whoever is flexible. So here also, which is flexible for us, we are going to make that as a primary key. So that is in our case, we made this as a primary key. So that will become the primary key of this particular table. So every record you can identify uniquely, okay, and no record without have this value actually. So that's all simply. Even primary key definition is also, you can tell unique plus not null. But the very standard, very professional definition is one of the candidate key is the primary key. So simple, that is what the primary key. If you understand candidate key, nothing is there in understanding primary. So but mandatorily every table should have a primary key. So always primary key is 1. And if you take the candidate key, there may be chance of having more than 0 or more than 0 candidate keys. But primary key is always 1 in any table. The next key, that is foreign key. So this is also very simple to understand this. So this is an attribute in one table which is referring in another table's primary key actually. So what does it mean? Let us try to understand with a simple example. So this is the EMP table which we have, and this is the DEPT table. So have a look. Now if you understand that the columns which have an underline is always by default it is a primary key. That is what the representation. Now if you come to the employee, every employee working under one of the department. So instead of storing entire department details, you are just noting down department number. If anybody asks what is the department name of the James, department name of the James, first you will take the department number. You are taking this 30, going to this particular table, and then here identifying where is 30, then returning the required details. IT he is working. So how you are working? So simply if you take this column, the values what you are filling, those should exist under this column actually. That is what this is referring here. That is what one table, this table under this is what an attribute. That means this column is referring another table primary key actually. That is what simply you can tell. This is going to become the foreign key because the data what you have here, this is not its original data. That is going to exist in some other table actually. So the value 30, its origin is not here. Its original value data, full data available here actually. So that is what this is going to become the parent. So parent table if you take and child table if you take, here the parent is DEPT because that is the main source of the data for this particular column, and EMP is going to become the child. So that's all simple discussion. So DEPT number. Now if I ask you under the EMP table, if you observe just these 4 columns, there is a column which is foreign key actually. So are you able to identify? So that is MGR. Have a look. MGR is nothing but manager. So that manager, so suppose the Krishna working under which manager? 101 actually. Who is 101? You are coming here. That is what you are referring the same table one of the column. That is primary key. So it need not be always the foreign key which is foreign key. This is also foreign key because it's a data. This data is coming from some other column actually. Likewise here. So what we can tell that the foreign keys, the reference column need not be in another table's primary key. It may be sometimes same table's primary key. So that is what possibility is there. So that is what the simple summary is what actually here. That is, one is DEPT number is the foreign key in the EMP table, which is referring DEPT number, which is for primary key in the DEPT table. Just if you don't understand sentence, but this diagram is going to tell you. So from this, you can make this sentence simply. So what is foreign key is always, hope it is clear. So it need not be always from the another table. We can tell simply also be there in the same table. So that is what example is. MGR is the foreign key which is referring employee number, which is primary key of the same table. So these things, without these things, there is no any advanced concepts actually. These core concepts we need to understand. And very simple, these are all regularly happening things in our real world. Okay. And this is the very important, and this we are going to see in many places actually, that is surrogate key. So what is surrogate key? Simple. It is a system generated key which is simply a unique identifier for every record actually. Of course, as mentioned, in many cases it is auto incremented. So like just like if you start with 1, then 1, 2, 3, for every record you are giving a unique sequence number, you can say in a simple words. But still, it is a system generated number. Of course, surrogate key is always going to become a primary key. But behind the scenes, why surrogate key is required? Why system has to generate the sequence number? That too, it is in a auto incremented following uniqueness and not null. Every record should identify with some number, and that should be a surrogate key actually. So let us see here the this data. If you see here, so this is the EMP data again. Under the same data, when you take it, observe here that initially 1 or 2 is there, who is actually a Krishna, and his department is 20 actually. Assume that this Krishna changed his department because of some reason. So what has to happen? That's what this is the present record, current record. So what is going to happen? So say with the same data, you are going to insert another record actually. So earlier we told that this is the primary key. This is the primary key. But primary key, is it now the primary key? No. If you observe, the number is repeated. So there is no uniqueness in every value. So numbers are repeated actually. So there will be such a situations in real world, definitely in many tables actually. At that time, you need to generate a system generated key. So or simply what you can actually is, in some tables, it is not possible to identify the candidate key actually. So there is no column with uniqueness and not null. Then at that time, you are going for system generated key, that is surrogate key. Now here if you see the employee key, surrogate key which is primary key, that is sequence number simply. Suppose the Karim changed his department number, or Karim moved to another manager actually. So what will happen? 104, so repeated value, name is of course same, this is okay, and he moved to the 101 actually. So that means you are going to keep like this. Then for him, customer key is going to become, so that means employee key is going to become 5, surrogate key, which is surrogate key. So like that, it is simply going to increment. So that is the system generated key. So hope it is clear that we discussed it till now different keys, that is candidate key, primary key, and foreign key. Now this is surrogate key. Okay, let us see the next one, very important. So that's what here the surrogate key if you see. So customer key is the surrogate key. That's what this one employee key actually. And employee number is the natural key actually. In general, this is going to become natural key which is going to useful for your business. Okay. So why we are discussing this surrogate key especially is in one of the slowly changing dimensions. This is going to play a key role actually. So that was fact table going to reference the customer key actually always. Okay. So of course this is for historical tracking. It will help you actually. You will get more clarity on these wordings in the upcoming discussion. Yeah. Now come on. Now let us see the next one. So now let us see the dimension and fact tables. So understanding always from the examples is very simple. So the core concept we will understand very quickly. So here if you observe that we taken some tables here, the sales, if you take any business, for example, for any business, there is a customers and there will be different stores, maybe across the city or across the country, and they may have different products in their store. And date wise, every day this business is going to happen actually, and then regularly people are coming and buying the products. That's what ultimately, right? So if you observe, these are the different tables. So which tables you can take as a dimension, which tables you can take as a fact. That's what the matter here, right? So if you see the store wise, suppose if you take the store, so every store, same companies, different stores will be there across the region actually. So every store you should have some name, and in which region it is there, who is actually handling that, who is managing that. So that's what this details actually. Likewise, different products, their product name under category and what is its price. Likewise, different customers will be there, and likewise everyday date will change. So date key is what, and day is what, month is what, year is what, and which quarter you are going to have a details here actually. Okay. Now, when any customer came, he is going to buy the product. What is happening when the customer came? Who is that customer? And from which store he bought that actually, and what is the product he bought, and on which date he bought. You are going to note down all these things. That is what sales you can call, right? And these details almost fixed. It's not fixed actually, it's going to change continuously, but this is not going to increase like anything. But regularly, if your business is really big, so hundreds of people regularly coming and buying the products. So what is going to happen? This sales data is going to increase like anything. Every day you are going to have 10-20,000 records adding to your database. And when you just come to the sales, who is the customer, you cannot tell just by seeing this table actually. Just by seeing customer ID, you cannot tell who is this particular customer you want to see. You want to see his address, where is he, what is his name, because he bought many details. He bought actually because of many products he bought over a time. So you want to give him a reward actually. Then how you will get his address, phone number, everything. Then you have to go to some other table by identifying its value, ID. So here you will get the full details. This is what descriptive, is it? And here you are going to have measurables actually. How much he bought, how many products he bought, each product how much quantity he bought. So accordingly, what is the price? These are the measurables. Simple. So text related data you will get here, full details you will get here, and this is the regular transaction details here actually. So now easily you can define what is fact and what is dimension. When you come to the dimension, it provides descriptive context actually. That's what, right? Every customer full details you will have available here. You will get it here. Every store full details you will get it here. Every product full details you will get it here. And facts are what actually? Store measurable data actually. That's what. So these are all you can tell foreign keys. That's what we learned just now, right? Have a look. And this will be the primary key, because you can say this is also sometimes has a surrogate key actually. Okay, and these are all, identify that different primary keys in each dimension tables. So dim is nothing but dimension. This is fact. Have a look. So fact is always surrounded by dimension tables. So fact table is not going to have a full data. Only in DBMS we have a normalization. So after normalization, only its related keys you are going to have here actually. This is going to increase like anything, the data wise number of records every day regularly inserting into this table. But dimension tables definitely not like a fact tables. So that is what first of all simple understanding of this dimension and fact tables actually. So if you continue this discussion further, the dimension tables what actually talking, what a fact tables is talking, if you observe definition, if you take, so it is simply descriptive contextual attributes you are going to have actually here. So simple, if you take a date, product, customer and store data, have a look, it is going to give the full information. So who is the so and so customer? You can answer it. What is the so and so product? You can answer it. When this particular transaction happened, you can answer it from this data actually. And where the product, why they product, why they where the products are bought, why they buy that. So all these things you are going to get the answers only by using these dimension tables. And in the dimension tables, who is going to play a key role? That is what the primary key. Is it? So, of course, surrogate key, that's what we are discussing. And then the attributes giving what actually, that's what textual or descriptive information. So and so customer name is what, so and so product name is what is the region, where, so these details you are going to get it actually. So hope it is clear overall what is simply a dimension. Full details you will be there, and these are going to change slowly actually. But in these tables data of course in general not going to append or insert not very regularly. Not drastically data is not coming into these tables. That's what simple discussion about the dimension tables actually. Come on, now let us try to understand what is these fact tables actually. So if you observe the fact tables, here the definition is very simple. And by seeing in the last slide this data, you can easily write down its definition. So fact table contains the quantitative data actually. So that means you are going to have mostly the numbers. So that's what, how much quantity, so and so customer 201 and so and so date he bought something actually. So what is that product, what is the, in where he bought it actually. If you see the mainly the measurables, these things. So how much quantity he bought so and so product and what is the total cost. So like that, of course many columns, but overall a data is like this. So that's what talking about the fact actually. Okay. So it is always in the center of the star schema. That's what the diagram what we seen earlier, that is the star schema only. Okay. Now usually it is very large. That is very important. Okay. So that's what in the data domain, in the data migration especially, there is another concept of loads. Different loads will be there. So that is what actually incremental load, full load. So on which tables you need to apply the full load, on which tables you need to apply the incremental load. Basing on this you can decide actually. So dimension tables most of the times it is a full load, and fact tables most of the times it is the incremental load because its size is really large. So all are interrelated. That's why we are discussing these things as a prerequisite. Now come on, see the characteristics here. Basing on this discussion, what actually here you are going to have a composite key actually by using the foreign keys. So foreign keys, what actually, these are the mainly primary keys in the dimension tables. So simple thing. So as usually as we discussed that it is going to have most of the cases numeric values. By using that you can go for the analysis actually. That is what mainly fact tables are going to help you to identify the insights in your business. So on so and so region how much sales is happened, and so and so product how it is performing. So all these things you will get from the fact tables, and if you need full details you will go for the dimension tables. So that's what, hope it is clear. If you observe overall, this is what dimension and fact tables. So that is what, if you connect them, as we discussed that fact tables is always at the center, and these are going to be connected with the dimension tables actually. So that's what, if you see the simple example here, if you want to identify product wise how much sales is happening, if you want to identify. So you see always it is a combination. Fact table is in the first position. That is what joins related concept. And you want to know product name actually. If you want to have product name, you should join with that corresponding dimension table actually. Then what is the relation between them? You are keeping it, and then you are performing group product wise. Then in each product, how much amount is generated, you are summing it actually. That's what coming in the output. So that's what is the fact and dimension tables. Very simple, nothing is there overally. That is what in the real world, if you see, if you want to understand in a simple manner, what is this one? When you go to any hotel, okay, what is going to happen? You are going to have a catalog in front of you. So that catalog is telling that what actually, so what kind of dishes are there, how it will be there, all those things. So at the end of the food eating is completed, what is going to happen? You are going to have a receipt. So what product you taken, okay, its ID, and how much you taken, and its a price. That's what simply you can say facts. So this is the simple example, but betterly you might understand already with the actual discussion. So this is what overally what is fact and what is dimension, and these are going to play a key role in our actual discussion. Okay, so now we came to the actual discussion, that is slowly changing dimensions. Okay, so whatever we discussed till now, the prerequisite, that is going to help a lot in our actual discussion of the SCDs actually. Okay, so come on, why SCD is required actually? Try to understand with simple examples always. So handling changes in dimension data actually. What does it mean? Okay, so dimensions are not static. They are going to change over a time. So they are going to change continuously actually. So you have to connect what I am telling with our previous discussion actually. So dimensions is nothing but what actually? So dimension is nothing but what? Suppose if you take a customer, so that customer given now some address. Then over a time he might be moved to some other place actually. So address is going to change. Phone number is going to change. If you take a price, so the price of a product is going to change over a time. Maybe every month price is changing. Category might be changing. So in the dimension tables especially, whatever data you have, that is continuously going to change, but not rapidly. That's what slowly it is going to change actually. So here if you take these examples, if you take the customer, his address might be changed here. So his address might be Ramesh moved to might be moved to Mumbai actually. So you have to change, you have to capture that new address actually, and product price might be changed next time. So different value is coming. So first of all, simple thing is that in these dimensions are continuously going to change. When they are continuously changing, the very important thing, when they are continuously changing, what is the challenge? How you will capture them? That is really matter actually. Okay, so how you will capture them? How do we store that history actually? So that is what SCD is going to come into the picture. So how you will store? So that is simply, if you see the definition, slowly changing dimensions, so that these dimensions are going to change, not of course rapidly, but definitely one product you suppose you are a seller, if you have 100 products in your store, and these product names will not change very rapidly, and these prices also every day you will not change it. In a year, you may change it for 2 times, 3 times, that depends of course. But it observe that these more majority of the products prices also not changing continuously. Product name if you take, that is very rarely is going to change. That's why it is calling as it slowly. But anyhow, some data is going to change. A simple understanding. Now, SCD dimensions are techniques to manage and track the changes in dimension attributes. That's what in those columns actually. So how this data over time going to change, and this data how you are going to manage, a simple understanding actually. So the key point here is preserves the business history. So and so customer's previous address is what, current address is what, when sometimes you need it. And some columns data, you no need to bother about its history. That is also matter. So for example, mobile number is there. You are always focusing on the current mobile number. You don't bother about the previous mobile numbers. So you no need to maintain the history. So how you will maintain that overall is actually SCD is telling. So that's what business examples address changing all these things actually. So overall, whether we are going to overwrite or we are going to store both. That's what overall discussion of the SCDs. So hope it is clear that what is really first of all SCD after understanding dimension tables. So in the dimension tables data will be there, but that data is not going to change really very continuously, but definitely here and there data is going to change, like product names changing, prices changing, or a customer address, mobile numbers, anything can change actually in the dimension tables. So when these are changes happening, how you are going to capture these changes? With history, without history, or specific columns history you want to maintain, or for some columns you don't want to maintain the history. That's what overall talking actually. So that is what SCD is going to come into the picture, how you will manage that. Now come on, let us try to understand different SCD types. Just a overview now, and one by one we are going to see its main meaning and its implementation especially. Ultimately we have to implement. Theoretical discussion is really very important. It is going to play a 80% key role overall concept wise, and 20% is the practical part. Nothing is there in practical nowadays. Just if you understand the concept, you can take the help. That means AI. Okay. But without AI or with AI, but theory is really matter. Come on. Now if you see the different types actually, SCD type 0 is talking what actually simply, you once the data is inserted, that is never going to change. Very simple. That's what it just outline. We will see. And type 1 is talking what actually. So the type 1 is talking simply overwrite the existing data. If you want to change something, you are just overwriting the existing one. So a simple update actually happening. So type 2 is talking actually the full history. So what is the previous value for so and so column? You can tell actually for so and so customer what is the previous address. Before that what is the previous address. So the duration also you can tell basing on the capturing values actually. So that's what full history you are going to maintain in the SCD type 1 and 2. So understanding these two is really matter, and remaining 4 or whatever is there basing on these two only. A little modification is going to become remaining type 3, 4, 5, 6. So just have a overlook. Type 3 is what? It is going to maintain partial history instead of full history actually. So maybe last 2 addresses only you want to maintain. That's all simple. Here full history. Suppose one customer changed 10 addresses in 5 years duration. So all 10 will be available. But in this case, if you want to maintain partially, that means last 2 addresses. So that's what accordingly. Okay. So you are going to maintain the history table separately actually. So the current active data you are going to keep in one table, and always history you are maintaining in another table. That is what type 4 is talking. That's why these two, first type 1 and type 2 is really matter. On top of that little extra implementation is remaining things actually. So then type 5, if you see the mini dimension, so helper dimension for frequently changing attributes. This is also a very simple thing. Instead of applying this history part for every column, only to the specific columns you want to go for history capturing. For remaining things, you don't bother, simply update. That means overwrite the existing values. That's what mini dimension type 5 is talking. And then type 6, it is simply a hybrid mode, a very interesting one. So that is what 1 and 2 most of the time, sometimes 3 also going to include actually. So combination of 1 and 2 is going to become type 6. So this is what just overview of these types. Let us try to deep dive one by one actually. Let us try to understand theoretically with examples, and then let us see its practical part. Okay, now let us try to understand what is type 0. So nothing is there, as it is mentioned that it is always fixed dimension, as telling here that. So keep original value, ignore the changes. What you initially given the value, that is going to become forever. So for example, you given the address initially Hyderabad, that is never going to change even if you give the changes. Even if you try to update, it is not going to update in the original. So gender also, if you give first time, that is never good, that is locked forever. That's what type 0, simple. Original value is always going to be there. Even if you try to change, not going to change. This you might observe in many times in your real time also. That means when you are applying for anything, or when you create the account, after that some values you cannot change. That's what simple. Okay. So that is what date of birth is one simple example. So this is generally going to useful when historical tracking is not at all required and you are always strict to the initial values. Okay. So that's what simple. Original account opening date or social SSN number, Aadhaar number, these things once you given, you can make it as a lock actually. So simple discussion, nothing is there to understand this one, type 0. Now let us try to understand the actual one, type 1 actually. Come on, SCD type 1. What does it mean? Simple line, overwrite with the new data. What does it mean? So changes occur in dimension attribute. Old value is going to overwrite with the new value. That's all. What does it mean? See, if you take this simple table, customer dimension table, this is the original table. Keep in mind now onwards, there will be one original table and there you are going to get the staging data actually, which you have to merge with this dimension tables. So this is the staging table. That means today some updates happen actually. So if you observe the dimension table, in this dimension table, customer 1 to the customer 1, the city is changed to Bangalore. What is going to happen? You are simply overwriting here with Bangalore. That's all. So that means what actually happening here? You will not get the previous value actually. What is his earlier city if anybody asks? Because it is overwritten, you cannot tell it actually as a Hyderabad. For us it is visible. Once if it is overwritten in the database, you cannot get it back. So understand that this is the staging data today. Some updated data is there and some new records are there. That's what you have to observe. So here for the record number 2, customer 2, so there is no changes. And for customer number 3, there is no changes actually. So one updated record is there, one new record is there. Then this you need to merge here. So one is update, that means simply overwrite, and another one is insert. This 4 is simply coming here, Priya Singh, female, and then Delhi. That's all actually the SCD type 1. Okay, now let us try to see this one practically in SQL side. So I am just sharing SQL Server SSMS window. Okay, come on, this is real understanding. Till now whatever we discussed, now let us try to implement that in this actually. So for this, we are going to take some setup actually. So we, to differentiate each type data, we are going to create a schema separately so that, have a look. So schema is going to create. So let us try to change the database. So come on, run this script. Yes. Schema is created. Have a look in the database. Go to the EFNDB and open the tables. Okay. So come on, just a schema is created. We can see under this some tables. I am going to create a table and some sample data inside the dimension table, whatever we see in the example. So whatever we see in there, have a look. We are going to make it possible in practical. So SCD type 1 table we are going to create. Okay. So that is what here, create the table. So this is the business key, customer ID, customer name, gender and city. So I'm just creating this table. So table is created. If you refresh, under this you can identify that one. Okay, so let it expand. Now we are going to insert some sample data. 3 records we are inserting here actually. So have a look. So it might be came under SCD type 1 customers. This is what. Now try to insert these records actually. So before that, if you observe the data is there anything under this table. So select star from this particular table. If you run, there is no data just now because we just now created. So this is an empty table. Now if you insert this data, 3 records are inserted. Have a look. Now all those 3 records in the database. So this is exactly what we are telling, this part, this original table, dimension table. So if anybody want any customer details, they should refer this dimension table. That's what very important discussion here. Now coming to the staging table also. This staging table is also matter. So I am taking the staging table script now. So same script and with the different data. That's whatever we seen on the slide. So have a look. So this is the staging table script. Have a look here. So here I am just creating the staging table. Have a look. The difference is only STG. Okay, customer underscore STG, customer underscore dimension DIM. And the same schema I am creating to have all of them at one place. Now you can refresh here. That table also you can observe. Okay. So come on. Now as usually even this table also not going to exist, not going to have any data. So if you see just like this, select star from staging, no data under this table actually. Come on, insert the data, 3 records, 4 records we are inserting and observe that for each record what is there. So this is what exactly this one. Okay, so with this, 2 tables are ready. You can take this script here and observe the data, how it will be in the both the tables. So let me run again. Yeah. Have a look. The data what you seen on the slide and what you are seeing here, both of them same. Here we should understand the first query is what? It is a dim table. So that this is the 3 records. Now these are the 4 records you came into the you got it in the staging. This you need to match with this one actually. So that matching you are doing with the technique called SCD type 1. That is the very important thing. So here the match is going to occur. So the main discussion here is customer ID here 1. Whenever match with the dimension table same customer ID 1, then you will compare customer name changed or not, gender changed or not, city changed or not. Because city is different, then this value should come here actually. You got the point. This value should come here. That means here instead of Hyderabad it should be Bangalore next time. That's what the script now, SQL script by using type 1 you need to develop. So we understand what is the type 1, but how you will do implementation. And this 2 is matched, but all the data is same. This is Anjali Sharma, female, Mumbai. Both the dimension and the staging data is same. So likewise for Suresh. But 4 is not matched with anybody in the dimension table. That means what once again, since 4 is not matched with anybody, that will be the new record. You are going to identify likewise. So matched means some updates may be there. Not matched means it is a new record. So that is simple, straightforward understanding, right? To conclude how to implement also. So let us have the data in front of us. Now let us try to develop this merge script line by line. So this is the original table, means it is the target table, keep that in mind. So here let us try to have that where you want to match. So this is the target table, and then to where you want to match. So from where you are getting the data, that is what the source table actually. So your staging is going to become the source table, is it? Now let us try to develop the script. So SCD type 1, how you will implement? Suppose if I take the quick steps here for better understanding, you are merging this source data with the target table using type 1. Okay? Now, what to do for the existing records? So you have to apply the updates. What to do with the new records? You insert simply. Means what? 1 is matched, existing. So data is changed, updates. 4 is not matched with anybody. That means entire record from staging, insert into this dimension table, target table. So in SQL, how you will implement that? That is what there is a concept called merge keyword. So by using merge, you can do that. So by using merge, how you can do that? So very simple. You have to take the target table first. So that is what. So let us try to copy paste the table names. So your target table is dim. Syntactically always after the merge your target table should be there. So that is what as target. So alias name I am giving. Then you are by using what actually? What is the source table? That is what the keyword using. Source table is what actually? STG. This is the source. So you are telling to the merge command that who is the source, who is the target. So it will understand, okay, ultimately I am going to update this particular table by using this source table. That's what the syntax is telling actually to the compiler. Now we need to give the relation between these two actually. When you can say it is matched, when you can say it is not matched. That's what the condition. So in the target, okay, customer ID of this target, customer ID of this source, if it is same, then it is existing record. Simple, right? So here 1 is equal to 1. Then 1 you can tell that ID 1, that customer 1 is already exist in dimension. So that's what target dot customer ID equal to source dot alias names we are using customer ID. That's all. So when this condition is true means, so in the staging one that record is exist already in the dimension. So that is you can take as a matched case. So as per syntax of the merge, when matched, then what you need to do? So you can tell that to the compiler. That means when match is occur, 1 is equal to 1 here. So this record exists normally. Then compiler understand, okay, this record is matched, the condition is true means. Then what we need to do? You have to perform the update. That's all. Update something. What you can update actually, so you can further purify, but now we are taking directly. So customer name might be changed. So that means target dot customer name equal to from where the data is coming from the source customer name. Then not only this column, gender might be changed. So where you want to update target dot gender column So from here, this you are updating with source actually if it is changed. So source dot gender. Then further target dot city equal to source dot city. This is what you have to do when match is occurred. It's a simple discussion. So done. What if it is not matched? So you have another case actually, when not matched actually. So that means when not matched. What you need to do? That's all simply there. So match is packed with different things actually. So not matched, matched, not matched, not matched by source, not matched by target. So different discussion is there. So now simply when not matched by default means you are targeting the actual target table. Okay, syntactically I am just talking. Okay, leave it simply. This condition is false. When this condition is false, what to do? That's what we concluded already. We need to insert because that is the new data. See here 4 is not matching with anyone. So this is target is not matched. Sorry, this source, one of the record is not matched with anyone with the source targets. So this record, for this record, what you need to do? That's what by default not matched by target actually. So you have to insert. Okay. So we are going for insert. What are all things you need to insert? So that is customer ID, customer name, then gender, and then city. Then these values coming from where actually? That's what these values are coming from source.customer ID. So you can copy paste all these columns and just add from where these are coming. Source.customer name, source.gender, and source.city. So this is what simply overall the SCD type 1 implementation. Okay. So don't forget to append semicolon at the end. So now if I run this simple script, what should happen? So now see, script wise it is always simple if you understand the concept. When any record is matched with the dimension table from the staging, any of the attribute value, that means any of the attributes dimension might change. That's why you are updating. That's what conditionally you are telling when matched, when not matched. For any record, if this is true means going to this particular case, matched case, then it is updating these particular columns. So this condition falls for any specific record, then what it is doing, it is going for not matched case. Then what is going to happen? That entire record is inserting into dimension table. That is what targets. Now, if you see overallly the discussion, if I run this script, what is the expectation in this dimension table? So this value should change to Bangalore because this is the current data, today's data where updates or new data is there. So Bangalore is his new city. So it should be in the dimension table, it should be Bangalore. And remaining 2 records not changed actually, but 4th record should observe in this dimension table, means in the targets. So let us run this script, let us observe the same. So I'm just running, if there is no errors, successfully going to happen. 3 records are updated, but for 2 records there is no change, but still update is happening. Further filtration you can do actually, because it is first time I'm just implementing like this. Further conditions you can keep it here so that if there is no change, you don't need to update for those 2 records actually. Come on, now let us observe what is expected. Is it happen or not? See here. Have a look. The first query is for target table, dim table. So dim table data, if you observe, Ravi Kumar's city is changed to Bangalore. Earlier it is Hyderabad. We all seen. And 4th record, it is a new record that is also there in the dimension. Because if see in the real time, this dimension table is going to serve to many other teams actually. So people are going to depend on this particular dimension table. So whatever changes is happening regularly, those changes should reflect on the dimension tables. So that people are getting the accurate data. That is what main thing. Okay. Because the address is changed, suppose something you want to post, because address is changed and people are dependent on this dimension, but whatever changes happen locally, that is not reflected in dimension. Then it is going to the wrong address actually, though he updated. So that's what the main thing. This is what actually the implementation side, how you can do in the SQL. So simple discussion, nothing is there. You are just understand that what is the target. Dimension is always target. The source data is what always from the staging. Then this source data you need to match with dimension. That's what match command we are using. Then relation between these two tables you should tell in the form of the condition. So that it is for which record it is true, yeah, that means match is occurred. When match is occurred, you need to update because we are considering that as existing record. Match there means it is an existing record. If this condition is false for so and so record in the target side, then that record is actually the new record. That means new customer came. So that new customer should update in the dimension. So that's what you are simply inserting. So here you can give comment as existing records, existing record. And here you can give comment as it is completely new record. That means you can say new customer. So this is existing customer, already existing customer. He might change it some dimension. That means city, address, phone number, whatever simply. That is what the implementation of this type 1. Let us try to see. That's what history is gone. If you observe here, if anybody asks what is the previous city of the Ravi Kumar, nobody is able to tell because it is overwritten. That is really matter. So that's what no history is going to maintain here. So that's what only the latest information you are going to have, the current data only you are going to maintain. Now let us try to understand. So overall, so what is type 1 actually? So basing on our understanding, the type 1, it's a real implementation. When to use it actually? So it is very simple that it is simple that we don't need a history actually. So old values you don't have any importance. So you can simply go for always taking the current value just by overwriting it. So like it's maybe spelling mistakes or phone number, emails. So these things you need always the current values actually. Okay. And always you need the current product price. So you can simply go for that. So it is simply overwriting. So wherever you don't need the previous values, you can go for this actually. So the advantage is what actually? It is very simple to implement. Okay, you don't need to take care of the previous values whenever you are getting a new value actually. Okay, so the table size is always in small. Okay, it is not going to increase like anything. And querying is always straightforward. So because there will be only one record always. By using business key you can get the details actually. Okay. So you don't need to go always for what is the current record, previous records, on which dates, all these things you don't need to bother. So querying is always straightforward. So this is what simply type 1, how it is working actually. Okay. Now basing on this discussion, let us move to the type 2 actually. So type 2 is simply straightforward. We are going to maintain here the history mainly. Okay. So as we discussed in the previous discussion also, type 1, type 2 if you understand, the remaining types is simply so type 1, type 2 if you understand, remaining types you can understand really very quickly actually. Because the mix of these two is actually the remaining. Okay. So in type 2, what we are really doing, we are going to maintain the history actually. So along with the new data, you are always taking care about your previous data actually, so that you are ensuring the history actually. So for example, to understand this quickly, have a look this one. So customer ID, customer name, gender, city, and when started, because here especially you are going to maintain the is current equal to 1. That means what actually, that is current record or not. So this is the initial data in case of the customer dimension table. Now, if you take the staging data, that means today this is the current data you got it. Okay. So in that, for the customer ID 1, some changes is happening actually. What changes happen? He moved to Bangalore. What is his previous city? For the customer Ravi Kumar, previous city is Hyderabad. So he is moving to Bangalore. That means what actually? In case of type 1, you are simply overwriting in this place. Instead of Hyderabad, you are just keeping up Bangalore. But now you want to know even his previous history also. You want to maintain that. Then how you will maintain that? So that's what, have a look in this actually updated customer dim table. What is happening in case of the customer ID 1? Have a look. You are maintaining this one. Current data is this one. How you will get to know? Is current equal to 1. So with customer ID 1, you might have multiple records actually. But always there is one record with is current 1. So that is what representing the current data. And previous data you can identify with the start and end dates. So that's what, when this is started, when this is ended. That means when he stayed in this particular city, you can tell by using this one. So that is what the history you are maintaining. Then why you need the customer key actually once again. Have a look, the customer ID is going to repeat multiple times. Because what is happening actually, the data continuously may be changed. So when data continuously changing, every time new record you are inserting with the same customer ID. So duplicate values, definitely possibility is there. So duplicate values will come. Then how you will identify each record uniquely? That's what surrogate key we discussed actually. That is, this is, you can say, surrogate key. So it is just an incremental number for every new record actually. Now you can see earlier we have 3 records. Now this is the 4th record actually. And it is updated also actually here in the end date. So these are all things you need to keep in mind. For the remaining, because there is no change for 2 and 3, those 2 records as it is. You can see the data wise also. And the new record is this one. So Priya Singh is the new record that is simply inserted. So from this, what we need to understand. So for the existing record, so simple discussion, what you need to do for the existing record. For the existing record, earlier is current is 1, you have to make it as 0. So that is one thing you need to take care. So is current, you need to make 1 to 0. That is one simple thing. And along with that, what you need to do actually, you need to update the end date. Because that date, that record is going to become history. It's not the current active record. So that's what. After that, along with this updated and new, both along with updated, new, insert action as a fresh records. So you are inserting what actually, both updated records and new records. That's what, right? Have a look. The 4th one, this record as it is, you just insert. And of course, new record, this Priya Singh is also inserted. That's all. So this is what really the type 2, very simple, how you are maintaining the history. Now let us try to see here how you can implement this in the SQL side. So now let us try to take the script for SCD type 2 actually. So here have a look. First of all, we are going to create the SCD type 2 schema so that we can differentiate all the tables actually. So this is what. Then let us try to create first of all the dimension table. So that is SCD type 2. Have a look the columns actually what are there. So here the columns are same. Okay. Customer key which is going to become the primary key and surrogate key. Okay, which is obviously internal it is surrogate key. How you can implement the surrogate key, that is also matter, that is identity 1 comma 1. So what is actually identity 1 comma 1 actually? It is going to start with the sequence number 1. Starting number is sequence number 1. Always increment by 1 actually. So when first record is inserted, it is that value for the customer key is going to become 1. Then when second record came, the current number is 1, 1 plus 1 is 2. So likewise, if you insert 10 records, for the 10th record, what you inserted latestly, for that it is going to become value is 10. So it is simply like incrementing the number. For that to implement automatically, you don't need to pass this value when you are inserting a record. You can use this identity 1 comma 1. So this is what is the starting value. You can tell like this, identity of what is the starting value and then what is the step, how much you need to increment for the next value actually. So that's what you can make it automate. So that is we are taking concept wise surrogate key, which we discussed already. Okay. So that's what the dim customer table actually. And obviously we need actually the staging table also. Let us try to take a staging table where we are getting the current updates. Okay. Then this you need to merge with the dim table actually always, right? So now let us have some sample data. So I am taking now, try to understand the flow, what is happening here. We are inserting this data. For example, now right now if you take select star from SCD type 2 dot customer dim and similarly customer STG. So both the tables if you see now there is no data in both. So no data right now. Have a look the columns also, customer ID, customer name, gender, city. Now, after inserting these 3 records, where you inserted, observe that. Have a look. 3 records we observed. Now, if you see the data in both. So, here, this is the first one is actually the main table, dim table, and this is the staging table. So, today you got this data. This is in first time you got this data like this. This you need to insert into the dim actually, always. So, how you can do that? So let us come here. So that data we are directly inserting into the dimension table. So this is the simple script. We are taking the data from staging and start date is going to become the current date and end date is null because it is not yet completed. And current is current or not, that means is it active record or not. Yes, obviously when you are inserting first time that is going to become by default active. So that is what 1. Okay. So I am just running this script. Now you can see the data, staging data moved to the dimensional table. This is what the change happened just now. So this is the first of all initial setup actually. Now the next day you are going to get the some updates to this staging actually, not this current data. So how and all, have a look. Some another sample data I am taking for this staging table first of all. So before that always if any data is coming to the staging means the current existing data you have to truncate because new data is coming, right? So you don't have any business to the yesterday's data that you can call as an incremental load. So that's what one of the concept in data data warehousing concepts actually. Now this data let us try to insert into the staging. So these are the incremental records or delta records you can call actually in the actual domain, actual data warehousing concept. Okay. So now let us see the data, what is there in these two, and understand that what to happen next. Okay. So see here, this is the customer ID 1, 2, 3 and the 4. Have a look what is happening here. As data inserted, what it is mentioning, city is changed. So for the Ravi Kumar, in the existing data it is Hyderabad, but he moved to the Bangalore. That means there should be one more record here as we seen in the slides. So it's the same data we are using for the easy understanding purpose actually. So this Hyderabad should be now the Bangalore. So accordingly one more record should come. But now that new record is going to become the active record. So that means this should change to 0. And it is already expired. This is not the current city. So you should update here that when it is changed, that means as a end date, and that this as a new record should go. Because there is no change to 2 and 3, you are not going to do anything, but for 4 you are going to insert as a new record, so that end date is null and the is current is 1. So the changes what to do, that's what we noted down here. For existing, is current should become 1 to 0 and the end date should update. Then for new records, along with that updated, you have to insert. That's all. So for that, what is the script in SQL? So very simple, straightforward. As we discussed for type 1, this is also a simple thing. So in this, let us try to understand stepwise. So we are clear that what is the source, what is the target. So this is what actually we can take it as a target table, and this is actually source data. What is that? See, dimension, ultimately you should match this data with the dimension. So that's why it is target. And the source is what? You have the data in the staging. Always, every day you will get the data in the staging actually. So that's what incremental records you can say actually. So that is what the merge command is telling. Okay. So we seen that for the type 1 also same merge. So let us expand this. Have a look now. Now what is the condition? What is the relation between these two tables? So relation here is what? Customer ID here and customer ID here. So that's what, put a relation dimension dot customer ID equal to stg dot, what is the alias names you given? Have a look. So stg dot customer ID. So this is the main thing here, and along with that one more thing you need to take care. Okay, so that is always you are updating to whom you should have the clarity. So listen here, in the data, in the actual data, let me run again this script. See, in the actual data, you are updating to whom is current. Over a time, you are going to have multiple records for the same customer ID 1. So every time you don't need to update for all other records actually. Only whoever is current is 1. For him only we need to change from 1 to 0 for that record only. So that's why in the condition mention that dim dot is current record equal to 1 or not, you need to check. Okay. So that should be 1. Only for that record you need to make the changes. Okay. So only for the current record you need to do this. That is what the first thing. For whom these conditions are true, though that record is actually existing current record. Existing, not just existing, and current record. So this is first condition telling that it is a existing record already, that customer already there, and this is telling that that record is active. So that is what when match is occurred, when matched, then what you need to do. That is what we discussed here, update. So That is what we need to take care here. Okay, but the thing is here, not only this, we have to do some more things actually. When matches occur, what to do? So along with that, you need to take care, is really data changed or not? Let us observe in case of the second record and third record. Customer name, here customer name not changed, gender is not changed, city is not changed. If these three values, because these are the three actual dimension columns, if these three is not changed, you no need to touch this particular record actually. That means this record you no need to bother, simply ignore. So that's what you are maintaining in this actually. So that meaning is what actually? Dim dot customer name, is it different? In case of different, you need to update. If it is same, you don't need to bother actually. So if it is different, yes or no, you can check that. So customer name, or there may be chance of another record, right? So dim dot gender, is it different or not? You are going to check stg dot gender, or dim dot city not equal to stg dot city. So if you have still any confusion, have a look what we discussed here simply. See, have a look what happened in case of, for the first record, have a look. Dim customer name same, okay, gender same, so condition is false in case of this one, and in case of this one condition is false. And when you come to the city, it is different. Yes, Hyderabad not equal to Bangalore, condition true. If any one of the condition in this brackets is true, overall condition is true, and it is already matched because that one exists already here and it is a current record. That means out of these three dimension columns, one of the column is changed. That is what overall summary for reason for writing this thing. Then what you need to do? Think actually. Then what you need to do? Then you have to go for the updates. That is what the main thing here actually. Then what you need to update for this existing one, because for this record this overall thing is true. Understand that. So what you need to do? End date you need to update, is current change it to 0. So that's all simple and straightforward actually. So then you set it. What do we need to set? So dim dot end date, make it current date so that it is going to complete actually. Then dim dot is current equal to 0. So you are making it inactive. Okay, so that's all with this merge actually. Okay, so with this statement what is happening, you are simply did this particular part. That means for the existing active records for whom data is changed, those record in the dim dimension table made inactive. But still this record is not inserted in the dim table. That's what new records and updated records not yet inserted in the dim table. That is what next you need to take care. So how you can write that? So here it is very simple. So I am taking this straightforwardly, the script. Let me copy paste. So have a look this script. You are inserting into dim dimension table and then from here actually. Okay. So here actually in general this 2 and 3 we no need to have actually in the incremental records. This 2 and 3 will not come. So what I will do is I will delete from stg.customer. So if you have like this, some extra conditions we need to take care. Now what will happen? Have a look. So this is the current existing data. So this is the updated record, this is the new record. You just have to insert. So here the main intention why I deleted now, here extra things you need to take care. So what I recommend is, if you have data likewise, that means if you have 4 records like that. So in the STG, the current data, if it is like this, okay, how you will do things in this case when you are inserting. So you updated earlier like that. Now you have to insert. While inserting also, you need to take care of the records which is not changed at all. If you have data like that, so now I am taking like this actually. So that means what? This data simply you insert into this table because already you updated here and here with that merge statement. So that's what actually you are simply taking the records from this staging, all the records, then you are inserting. Then for this start date, you are giving the current date. For the end date, of course, it is null, and the is current by default it is 1. So that's all actually. So let us run this step A and B. So in step A, what is happening? Have the clarity that for the existing updated record which is active, you are going to make it inactive by updating end date, and you are inserting the all data from staging as a new data. So that's what both the things happening. If you want to check individually, let us run this first merge statement. Now let us run this again. So one record is affected. Have a look that effect, how it is happened. So run this. See, end date and is current is 0. You made it inactive. Then let us insert. Of course, all this script actually in general you will keep in a stored procedure. You can run this actually. Then 2 records are inserted. Have a look how dimension table is evolved. See here, the 4th record came, and for the customer ID 1, then you can see his city is Bangalore. So customer ID 1, if you observe, Hyderabad to Bangalore he moved actually. And what is the currently active record? Just by searching is current equal to 1 for the customer ID 1, you can get the details actually. And of course, this is a new record. So as usually you insert it as a active record. So that is what the type 2 actually, very simple, straightforward. Okay, so that's what overall the implementation wise, this is the advantages. If you observe, basing on this overall discussion, what are the advantages actually? So this is simply preserves full history. So you can go for past as much as you want to go, as much is existed, that entire history you can get it back actually. So that accurate history report you will get it actually, and it will supports a trend analysis. That means what actually, over a time how one customer is evolved. That means what his customer, suppose product is there, how the prices are changed from over a time, where it is started, where it is, how it is moved, you can analyze in that way also. Okay, then especially compliance ready means what actually, essentially in industries actually where audits are frequently going to happen. So you can tell that it is in banking, healthcare, insurance. So this kind of flexibility will be there if you implement type 2 actually. Then if you see the disadvantages, the very first thing coming to our mind is what actually, whenever a simple change is happened, even for a small change, it is going to insert new record. So size of the database is going to increase. That's what a very simple thing. And then complex ETL logic we need to write down. That's what merge statements or update, insert, by using these surrogate keys, all these things actually. So you need to use many keys, many columns to write the logic actually. That's what it is obviously working on slower queries actually, because you need to go for joins, okay, and you need to apply the conditions more actually is current or not by using effective dates and all. Okay, so that's why, because conditions more means it needs to check the conditions more and more for every record. So obviously it is going to slow down the queries actually. So then you are going to have a maintenance overhead. Okay, so for validating, managing, and for debugging actually. So but it is a trade-off kind of thing actually. Basing on the situation, you can select which one is better. Okay, so this is the type 2 more or less, and this is the entire thing of the type 2 actually, how you can manage it. Type 1, type 2, having said that, if you are clear these two, then all other types very easily you can understand. So that we will feel it. Now let us simply try to compare these two actually. So before that, if you see key points in the type 2, because this is really very important, that's why we are focusing more and more on this part. Because remaining things, simple modifications of this type 1 and type 2 actually. So the main thing is surrogate key, as we discussed earlier. We seen the keys in the initial of the discussion. So surrogate key is going to play a key role here. So that's what we felt that. Okay. So every record you need to identify uniquely. So surrogate key came into the picture. So it is going to become the primary, not the business key. Business key is customer ID actually. Okay. So in the database, if you observe, this is the business key. But this is not going to play a key role to identify the records, but this is actually a primary key. So that's what the main columns what you need to identify, business key of course, and then attributes. So customer name, city, gender, these are the attributes may going to change actually. And then going to play key role is what? Effective dates. That means what? From when to when, the duration you can identify, so and so data is active. Okay, and very crucial thing is what? Current column actually. So that is the thing. Then business decisions, of course, if you want to maintain the history, then you can go for this actually, SCD type 2. If you don't bother about the history, always focusing on the current data, you can go for the type 1. So what is the optimization? This is purely if you are doing in the SQL side. Of course, in any tool it is there. Optimization wise, because the repeated data will be there under the business key actually. So customer ID may be changing continuously the data. So that's why repeated data one may come many times. That's why you can go for the partitioning or indexing. Basing on the same value, you are going for some partitioning, so that some performance effect will be there actually. So you can get the results in less time. So that's what purely SQL side implementation. So this is one of the concepts you can apply on these keys actually. Then at the same time, hybrid approach. If you want to save the storage, and at the same time if you want to maintain the history, that's what type 1 and type 2 in upcoming discussions we will see this hybrid approach actually in one of the type. So that is if any, some, just like as mentioned here, for some columns you can exclude actually. So if for some columns if you want to exclude, then such a way SQL script if you update, then you no need to maintain history for every record. So as telling here that suppose spelling mistakes will be there, so you no need to bother too much about that. So that time you just update the existing record. For example, if you take this the customer ID 4, so in the next iteration, in the next day, suppose he changed his spelling. So Priya Singh changed her spelling actually. That time, instead of updating end date and is current to 0, you keep it as it is, just update that here actually. So that modification do in the script, then you no need to insert a new record for this particular column. So that's what, on top of this, anything we are in a position to do actually, if you practice this well. Okay. So this is what very important, SCD type 2. In interviews, this is one of the most definitely people are going to touch actually. So give the high priority to understand and implement this more than to understand the real depth. Try to implement this actually, so that you will be really confident in interviews and in the real time. Okay, so with this you can compare this SCD type 1 and type 2 actually. So these are all these things we just touched in different places. So historical data you are maintaining or not, storage requirement more or less, so complexity, so code wise how it will be, query performance, because it is straightforward, it is faster, and it is, you need to apply more conditions actually. So best for what actually, so basing on your requirement you can go for this or not, which one you can take it actually. So history need or not, only current data is need, and the data accuracy you are just overwriting and you are maintaining everything. So basing on our simple discussion till now what happened, so these are just some differences actually. So this is what SCD type 1 and type 2 give. First of all, for these two the very high priority, then nothing is there in the remainder. So we are moving to the next types, that is SCD type 3. Okay, it is straightforward, try to understand. It is going to track the history in a limited manner. What does it mean? So it is going to store partial history. What does it mean? For a specific columns, if you want to maintain its history and not entire history, only current value and previous value. Okay, even if he did 10 changes on a so and so column, current value of course always has to maintain, and before that what is the value you have, only these two you are maintaining. That is what type 3 actually. This type 3 can extend, that's why partial history stick to that. It need not be always current and previous. Current value of course, previous value of course. Likewise you can take before this previous also another value you can maintain as another column. So such a way data movement is going to happen. So simple understanding, let us take this example, customer table 101. So Rahul, Delhi, current city is Delhi. So previous city is null because this is first time the data is there. Now assume that he moved from Delhi to Mumbai actually. So this is current city. So under city, normal city column, Mumbai is there. Then this is moved to the previous actually. So before inserting here, you can move this data to here actually. That is what whenever first changes happen. Observe that one more iteration. Suppose from Mumbai he moved to Bangalore. Then this is current city, so Bangalore, and previous city is what, Mumbai. That is moved to the previous city column. So how it is moving, observe that. So null overwritten with Delhi in the first iteration, and then Delhi overwritten with Mumbai in the second iteration. So this is the current existing state of this particular customer ID actually. So only this is available in our database. So you can able to tell that what is his current city and previous city. You will not get back what is his initial city Delhi, because 3 times he changed it. So that is what the type 3 actually. So let us just try to understand for type 3 also. Straightforward, I am taking the entire script at once. Easily you can understand, nothing is there in the overall discussion. So this is the overall script. So type 3, we are going to create the schema first of all. Let us create it, and then let us try to create the dim table as you seen this current city and previous city. That's what this is matter. For which particular column you want to maintain current data and previous data actually. So that table we are taking here. Run this, and then we are just inserting initial data with 3 records. So obviously previous city is going to become null because you are inserting the data first time. So that means he might join initially now. Okay. Then we are going to have a staging data where we are getting the updates. That means the incremental data or delta data actually. Then take this data now. Have a look what is happening here. City changed as we seen for the Ravi Kumar. It is moved to currently he is staying in Bangalore. That means earlier city is what? So earlier he is staying in Hyderabad. Okay. So that is what update is happening. Now let us see the merge because we already mastered this till now. So we are taking directly this script. Have a look. You are merging with the dim, so target with the source staging. Then obviously this is the standard condition relation between these two tables actually. When this is true, that means matched. Not only that, if city is not equal actually. So that is very important. So have a look here, current data if you observe, you can easily understand this part. So run this. Having said that, previous two if you understand, these two straightforward. Have a look. Yes, match is occurred. See, understand the conditions. 1 match is occurred. Since match is occurred, moving to the when matched case actually. Then city here, not same. That means that's what you kept the condition here. When matched, of course, 1 is there, 1 is there here, and 1 is there here. But this is Hyderabad, this is Bangalore. Staging data is this one. So both of them not same. Yes, it is correct. In case of above. See, both the cities not same. Correct. When it is not same, then you are going for this particular part. What you need to do? Of course, from the source you are taking same data, but you see here, especially this particular line. What is happening? Your current city, that means this Hyderabad, should come to previous city. That's what previous city equal to current city. Then your current city value should update with this staging tables city. That's what source city you are writing into current city of the target. That's what actually move current to previous, overwrite with the current actual new value. That's all. When it is same, if customer name it might be changed, you are just overwriting. That's all. If this is basing on completely the situation actually. So sometimes you don't bother. Sometimes actually some columns never going to change. You don't need to touch them in the merge statement. So that is completely different. Mainly stick to this particular part. Okay. Then when no match is occurred, obviously that is taking as a new record. So that's what we are inserting. So now if I run this script, what is going to happen actually here? Have a look. This record you can observe here in the same record only previous value and current value is going to update, and this fourth record we are going to see here. So let us run this whole script. What to happen, first of all keep in mind, so that is as per expected this statement is running or not, you can cross check, so that in that way you can make the things permanent actually. Now run this and let us understand, is it running as per expectation or not. So you see two records is affected, one is update, one is new record. So have a look the data as per expectation, it's there or not. See, earlier city is Hyderabad, yes, moved to the previous, now current city is Bangalore, and a new record is inserted. So this is what actually SCD type 3. So very simple, you are just maintaining previous data and current data. So that's all SCD type 3 actually. Okay, now let us move to the type 4. What is happening in type 4? Quickly we can complete all these things actually. So history table approach. So what we are doing is simply we can keep two separate tables. So one is for current data, always for active records,
Hey, if you
and
don't
another one is
subscribe
for
till
history
now,
actually.
please try to
So
subscribe.
that's all.
Thank you.
So dimension table, actual dimension table is small, and you can get that results very quickly actually. And when you need a history data, you will go for the history table actually. So for auditing and all. So mostly this kind of approach also people are going to use. So whatever, it is simple. Now for this type 4, let us observe that how it will be. So now let us see how to implement type 4 in the SQL side. So here we are just creating the schema SCD type 4 so that we can identify all of them just like a remaining SCDs. Now let us try to create the dim table. So as you see here, customer ID, name and city, and the primary key is customer ID. So let us create this one. Then let us have some initial data into this particular table. I am taking the 2 records. Have a look. So 2 records are there. Let us create the history table also. But in case of the history table, as you see here, surrogate key is matter actually, because the same customer can change the dimensions, can change the data, maybe like his name or city multiple times. So whenever he change the data, with the same customer ID, record is coming into history table. That means this data is going to repeat. So customer ID is going to repeat. You cannot use it as a primary key. So that's why you should go for the history ID. It is just like a surrogate key. So to implement the surrogate key, you are using the auto increment actually. So that's what identity 1, 1. So as we seen earlier also, that's what simple. So let us try to create this table, history table. Now let us have a staging table where we are getting the new updates. Just like it's a staging is always like a incremental data, delta data actually. Now let us try to have some sample data in the staging actually. So now if you observe, by having the data in all these tables, let us try to see the data in these 3 tables actually. So that means select star from. So one is SCD type 4 dot customer dim, then another one is history, and another one is STG. So now if you see all these 3 tables data, then you can understand what to do actually. Now if you observe, this is history, this is staging, last one is staging, first one is dimension. Now if you observe in the staging, the Ramesh Kumar's city is changed, Bangalore, but in the actual dimension table it is Delhi, it should be updated. That means this should come to here actually. But before that, very importantly, you should not lose this data actually, because it should capture in the history table. That is what middle one. So this should come here with the history ID 1 and the customer ID 1, Ramesh Kumar, and Delhi is in the city. And of course current date. That is what should happen after this actually. After this merge, this staging data merge with this dimension table actually. So for that, let us try to see its implementation. Have the data always in front of you, then try to understand what is the script here. So my sincere request is, please try to type everything manually. Don't try to copy paste these scripts, because that will not help you to understand real depth. Let us try to take the dimension table as target, then staging as a source. That's what, right? Now relation between these 2 tables is what? Customer ID. So when there is a match, what does it mean actually? So 1 equal to 1 here. So that means match is there. That is what this one is going to tell, condition. When there is a match, that's what the condition case, when there is a match, and especially for the column city you are implementing this history. So in this case, suppose in this case city not equal to staging table city. So when there is a change, then only you are going to implement actually. So that's what this data, Bangalore, you are overwriting into this particular place. That is what actually happening here. That's what you see, source city you are taking, you are overwriting here. But the thing is here, the very important thing is, if you overwrite this Bangalore to this Delhi, then how you will get this previous value? That means Delhi, how you will get it back? That's what at the end you are going to see there is a script called output. So what output is telling? Whatever you are updating, from that you can get back the some values actually. What are those values? Because you are updating something means something you are updating. That means already some value is there that you are updating with new value. So when you are updating with new value, there is a concept of old and new. So old value sometimes you need, new value sometimes you need. So that's what here actually. So you should have the clarity what value you need, old value or new value. So here old value will become Delhi, new value will become Bangalore actually. If you need, we need old value, right, to capture in the history table. That's what the command you need to use deleted. If you want new value, in this place you have to use inserted. So that's as simple as. Now we need old values, that is customer ID, customer name, city, and of course current date. That's what in the history you are updating this change date. So these 4 columns you need to capture. That you are inserting into, this is the command, this you are passing, this output you are passing into this history table to these columns. And we don't need to bother about history ID because it is identity column. So auto increment value will come into this place. That is what the merge script, how simple, just try to understand overall. Nothing is there in this whole script, have a look. So that is when match is occurred. But simple, when not matched, that means it's a completely new data. So in case of new data, we no need to bother, simply insert into the dimension table. That's what this script, you are just copying from the source, that's what staging, and then inserting into the dimension table, that's what targets. So that is what overall. So here the new thing to other scripts is this output, and now it is every word is clear. So whenever update is there, such a way you can bring the values actually, either previous values or new values actually. By running this script, what should happen? So let us try to map quickly, then let us run this script. So this Bangalore should come here, and along with that, this particular one record should come here. That is what should happen. If I run this script, have an observation. So 2 rows affected, let us see how it is affected. So run this 3 tables, have a look. So here this Bangalore came here, that is one thing, and this record is also came here. Delhi, previous value you preserved, that is very important. But without there is no change, so here for the Priya Sharma, earlier it is Mumbai, and now it is moved to Chennai. So that also captured. So this is what simply SCD type 4, how you are merging. So history table is this one, and this is dimension table. So that's all actually. Okay, so this is what SCD type 4, how it is implementing. Now let us try to understand type 5. So this is also just a simple extension to the previous discussions. What is that one? Try to understand. SCD type 5, it is just like a mini dimension or the current dimension. That means, have a look, the current values you are maintaining in the main dimension, and the historical tracking for few attributes actually, not for every attribute. The difference between type 4 and 5. So in the type 4, if you observe that every value you are capturing, but in type 5, we are not capturing every value. You know that which specific attributes need to capture its history. So for those only you are going to capture actually. Okay, that's what, instead of storing historical values, okay, we are separating them in the mini dimension table. So how and all, it is also going to reduce and we will get the faster results. You can take this example here. Here, out of all the columns in the main dimension table, have a look. Just try to understand first this one, then we will see different versions. Here if you see customer ID main dimension columns, customer ID, customer name, city. These are all supporting things, customer SK, surrogate key and minimum dimension SK. This is from this table, so this is foreign key here. So here if you see, you are giving much importance to the city actually. So the city is the highest priority for you. That means to track its changes. That means history you want to maintain. Then you can come here. So current value for this Ramesh Kumar is Hyderabad. If you want to track his history or if you want to see his previous values, 1002, you can go here, 1002, you can come here. This is the active record. And with the customer ID, you can get back all his history from the mini dimension table. That's what actually. And who is active, you are able to tell this. Actually, sometimes in the implementation, we are going to see even this column we will not maintain here because there is a redundancy, right? So this column you no need to maintain here actually in the customer table. Come on, now you can see, if you see the first iteration, what is going to happen. So he moved to, for example, Ramesh Kumar moved to Chennai. That's what in the current city it is in Chennai. Before moving this person to Chennai, this record should capture in the mini dimension. And he already, see, he already there with 2 records. Now the current, this is surrogate key means he auto incremented 1004 and same customer ID and this is what current city is Chennai. It is the active record and then remaining details. So that's what, if you see one more iteration, if he moved from Chennai to Delhi, so just have an observation, customer ID and its SK, then the current city. So in the main dimension table, this is not going to maintain actually sometimes. That depends actually basing on the storage, basing on the your flexibility. So let us try to observe this SCD type 5 in the discussion. How you will implement this. So confirm that here also we need 2 things. One is main dimension table and another one is mini dimension table but not all the columns. Okay, so that should be, that we should have a clarity. Take now the SCD type 5 script. Let us try to create the first of all as usually SCD type 5. Then have a look, the tables, mini customer dimension table we are creating first. See here, so that you can see here the meaning wise also, this is the primary key. Okay, mini dimension 1000, not so you are starting the value from 1000 actually. That means initial value, and of course it is primary key, but it is in the background it is a surrogate key actually. So customer ID, so city is the main dimension attribute. So slowly changing attribute is city actually. That's what you want to capture, and of course other stuff. So active flag, when started, when completed, all these things. So let us try to create this table. Done. Then we need to create a main dimension table where actually have a look the relationships here. So here the customer SK, of course here also this is up to us actually. So you can take a surrogate key here also, and customer ID, that is what business key, and then customer name, mini dimension SK, that's what you are referencing to. Mini dimension SK actually here, this column. That's what foreign key relationship you are establishing here. So this is foreign key, this column referencing in mini dimension table. Let us try to create this one. So basing on this relationship, This is the parent table here. Many dimension is the parent table. So, and this is the child table actually. Main dimension is the child table. So have a look. So that's why we are inserting the data first of all in the mini dimension. Some data we are inserting. Let us insert some data. 2 records are inserted. Now let us insert 2 records in main dimension. So to keep these values 1000, all these 1000 and 1000 not 1, here it is created already. Otherwise, if these values don't create it, it will not allow you actually to insert. That's what you are referencing. To keep any value here, that means under the column, the mini dimension in the main dimension table, okay, that value should exist in the parent column actually, parent table column. That's what here. Have a look till now the data in these 2 tables. That's what. City column exclusively we are maintaining in the mini dimension. So that is what current data, both of them are active. If you need the city column current data, you always join these 2 tables with this column and this column, and you will take a active flag as y actually, so that you will get the current city. If you need his entire history, then you will exclude this, then you will take the where customer ID equal to some so and so. That's what actually the current data have observation, end date is null because those are active. Now let us have some changes. That's what staging table is coming to the picture. So in general in the medallion architecture there is a concept medallion architecture. So in the medallion architecture we are going to have a bronze, silver, gold layers actually. So the staging is in general you can call as a bronze layer. So the data what you are fetching from on-premise or multiple sources, you are keeping in the bronze layer. That is what staging area, most of the times you will use it as actually. So this table is created. Come on, let us try to insert some data into the staging where changes happen. So if you see the whole data now once again, so come here, let us see the whole data first of all, including staging. So that what to happen, let us map in our mind. So for the Ramesh Kumar, earlier city it is Bangalore, now the current city is Hyderabad. For the Priya Sharma it is same, not changed. Now what should happen actually? That is what very important. The thing is, this record should come here, C001, Ramesh, city is Hyderabad, and the active flag is Y for this new record. And here it should become N. No. And the end date should be there. That is what change in the history. So the total records are 3 and mini dimension SK value is 1002. That should be updated here. That is very important. Because that is what current one, active one. So that is what the relation between these two keep in mind. Why you are maintaining here this one is the active record, the current city's record of the history you are maintaining here. That's what the thing should happen. So take the script now how we are going to implement. So very simple, straightforward, have the data in front of us. This is the step 1, what to do. The step 1 is close the old mini dimension record if city is changed. That's what here, make this as no and update the end date. For the Ramesh Kumar it is changed. So now you need to join these 2 tables, right? So this history and staging. So mini dimension and staging you are joining. Upon the relation is what? Customer ID. Okay, C001, C001. But sometimes C001 maybe exist multiple times in this history actually, because he might change the city multiple times. So for whom you need to change? Whoever is active. That's what in the mini dimension active flag should be Y. And at the same time, for whom you need to change? Whenever city is changed. Observe for the Priya Sharma, also it is Y, but the city is same. So you no need to bother about this particular record. you only has to bother about this record because city is different, Hyderabad and Bangalore. So that's what it should be different. So that is the relation. Now, when this is satisfying this record is satisfying. So change this value to n, change this value to the end date. That means maybe the current date mostly. So that's what get date. So these two columns you are changing as we discussed. So come on, if I run this particular script, what is going to happen? This record especially changes you are going to observe. I am running this script. Now, if you see once again the whole data, the changes if you want to observe, say this is changed to n and this is end date. Now, next what we need to do? In the second step, have a look what to do. Okay? So in the second step, insert the new mini dimension record for the changed city. So because city is changed, right? So here observe that. This value should come into here as a new record. That's what the another thing. Then that means what actually here? Say here always, here what should happen? In the from clause, have a look. So again now staging and again the mini dimension only. You are working between these two only still. Then the relation is customer ID and city for whom it is changed. Yes. Yes, city here is changed, here it is changed. Now for them, what is the value you have to keep? So customer ID, city, and this by default it is the active record. So set as Y and get date, end date is the null. That's what it is null. So that you are inserting into the mini dimension. So after updating to the existing current active record, you need to insert that record as a new one. This record as a new one in the history only. Because city you are maintaining only in the mini history table. So I am running this so that you need to observe 1002 and the remaining details. So have a look, one record is updated, let us observe the data. So you see the third record as a new record, active record and end date is null. So that is what in the step 2 you are performing. Then what else you need to take care? Very important also. What else we need to take care? Because this is the current active record. You are still pointing to the not active record actually. Because this is not active. The current city is Hyderabad. So 1002 should update here. That's why you are updating. So now you see the from clause first of all. Mini dimension you are involving. Staging you are involving. Main dimension. Staging. Yeah. Here. So here main dimension we are involving. Staging we are involving. Mini dimension we are involving. Because all of them is matter to check here actually. How and all? You see, of course, relation among all of them is customer ID here, customer ID here, customer ID here. But ultimately you have to update here, keep in mind first of all. Then for whom? In the mini dimension, the record whichever is Y. So because you have to identify whoever is, because C001 2 times it is there, but you have to consider this because this value you need to take it out. That's what this one. Mini dimension SK value you are taking. That we are updating in mini dimension SK, which is main. You are updating main, which is alias name of main dimension table. That means now after this script is executed, 1002 should exist here. So have a look how it is happening. So 1002 is updated, and of course this is also updated for this one. That's why 2 records updated the statement output you seen, but it's okay. So this is 1002. Now it is the current record active current record you are pointing from this main dimension. So this is SCD type 5. Hope it is clear. Okay. So overall, three tables here involving. One is main dimension, and in the main mini dimension you are maintaining only required attributes which are slowly going to change, and those you are going to capture in the mini dimension table, so that entire columns history you no need to bother sometimes. So at that time like this, and instantly you can get the fast results for the active records also. And storages, it is not increasing. This is what the SCD type 5. Okay. So upon understanding 1 and 2, as we having said that, it is a simple extension. Then if you see the SCD type 6, okay, so this is also simple, straightforward, overall nothing. Have a look what just it is doing actually. Type 1, type 2, type 3 as it is showing. And you see as type 1 you are just maintaining overwriting, and then as type 2 history you are maintaining, and as type 3 previous values are also maintaining. Just before this, just before current value, before that what is the value you are just maintaining here. So how and all, let us observe a simple example. Have a look, this is the initial load. So in this you see that you want to maintain the city history immediate values. So this is what actually how you columns observe that customer key, customer ID, customer name, city and previous city, and then start date, end date, active flag. For example, if he moved from Delhi to Mumbai, then what will happen? Observe here. You are capturing all the details of this city actually, but in the same table. In the active record, immediate previous city also you are maintaining. That is what the main difference. What does it mean? Have a look here. The 101 is there. Okay. John, same John. Mumbai is the current city because active flag is Y. What is his previous city? You can tell in the same record by taking the previous city column. Delhi. So this record is as it is, only end date is updated, and active flag you made as no, because earlier it is yes and end date is maximum you taken, that you can take as a null. So that's what. Now when he changed it to new city, only for the city column if any changes happen, of course you are taking a new record. In the new record you are maintaining previous city also, and current record you are making inactive. So if you take one more change, suppose from Mumbai to Pune if he moved, then what is going to happen? Have a look here. So in the Pune is the current city, because active record if you observe, and previous city is Mumbai. Yes, it is correct, previous city is Mumbai. And history also you are able to tell. History is there for this column, and in the active record you can tell previous city also. That's all, nothing is there overall. So let us try to implement this one. Before that, just understand what to do. Technically now you have to prepare in your mind. By this time you should be mapped actually. So what has to do? If match is occurred from the staging table with a customer ID, current active record make inactive. That's all. We don't need to do anything. But here something is logical. You make it inactive. Okay, fine. But on top of that, you have to insert new record and take from staging. From staging, you will get the current city, and from previously active record. Previously active. This is also important. Sometimes, so see. Previously active record is how you can tell after inserting this, because both of them n. So previously active record, whatever updated recently, from that you should get the current city, that is going to become the previous city value. So these things you have to implement. Let us try to take in new query. Let us try to take the script of SCD Type 6. So this is also simple, straightforward, nothing is there. Have a look one by one. Let us create the schema. Done. Now, first of all, let us try to create the dimension table. Observe the columns, how it will be. So, as we discussed, the columns here, if you observe, surrogate key, primary key actually, identity function we use it for auto increment, and then customer ID, customer name, gender, city and previous city. That's all. Of course, start date, end date and active flag. So create this and then let us try to insert 3 records as you have here. Done. Now at this moment, if you see this table data, select star from SCD Type 6 dot customer ID. Run this table. Have a look, all are currently active. That's why previous city, of course, that's why end date is maximum possible date taken. That's all. So the previous city is null because there is no history for them till now. This is first time. Now let us take the staging table. Let us have some data in this. So while inserting itself, observe that for which columns you have a changes. So city changed for whom? Ravi Kumar, Bangalore. So earlier cities is what, just have an observation here. So run this script, observe what changes happen. So Ravi Kumar's current city is Hyderabad, but now in the latest data he moved to Bangalore. So that should accordingly update here. And there is a new record for Priya Singh. So for him also, for her also, there should be a record here. So that's what this record should update. This record should be insert and this record should be insert. So that's what steps wise, hope it is clear. We need a temp table to capture this temporary results. Let it be, I will come back actually, we need to create before running this script. But let us understand this meaningfully, then we will create that. So as usually here observe that, very interesting this one, dimension table, okay, and the staging table. You are merging this data with the dimension table, that's what these two. And relation between these two as usually like others, this is a customer ID is the relation, that's what. Now for whom you are going to do, in the main dimension table, that's what target, for active record you are going to do actually. So now match is occurred. So one is there, one is there, one is there, and it is Y. So match is occurred. And match is occurred for even 2 and 3 also. But for them, city is not changed, Mumbai and Chennai only. So why you no need to consider these two? So that's why for whom it is changed. So yes, Hyderabad not equal to Bangalore. That is true. That's what relation you kept, logical condition. So for this record, these two conditions and this condition satisfying. So this you have to make as inactive. That's what here you are doing. Have a look. Active flag you are making N and the end date you are making with current date. But very importantly, before updating this, you are capturing some values actually. This entire record values you are capturing. In that what you are taking, customer ID, customer name, gender, customer ID, customer name, gender, these three from main dimension table. And updated value you need actually. What is updated value? This one, Bangalore. Bangalore you are taking from source, that is from staging table as a new city. And previous city going to become what? When you insert this record, this Hyderabad. So previous city you are taking from deleted. This is we discussed in type 5. So that's what you can take it here. So these are the records you need actually at this moment. so that you can insert as a new record as a active. And one more thing. So before updating these two, while updating this, try to capture these three values from this, and of course this city going to become previous city. Under that the previous city, new city, current city is what? From the staging Bangalore. That's what source that. Observe that what you taken here. That you are taking into the temp table. Temp table, if you don't know, simple. In this particular session, it is not going to create a table as a physically in this tables list, so that later you cannot see it actually. It is just in this particular session, this particular table is going to become active. So that is what temp table. So in the temp table you are capturing customer ID, name, gender, new city, previous city. So it is mandatory that that temp table also, like other tables, you have to create. So see the 5 columns you are taking actually. First you create the temp table to capture those values. So have a look, you can see those changes physically if you run this script. When the script is run, first thing is the existing active record should be updated, and in the temp table, what you are going to insert as a new record has to observe. Run this script. Come on, check this now after this. So if you see, you go to the end. If you see all these 3 temp table, including temp table. Have a look. First of all, that record made inactive and end date is this one. And if you see the temp table, last one is temp one, right? Temp table, right? Temp table captured what? The latest information which you have to insert in this table. That's what one Ravi Kumar M with new city Bangalore and previous city Hyderabad. So simply this record now has to insert into this main dimension table. That's what the next step after updating. Have a look what is happening in this particular. So here this is what just now we seen, merge statement. Then in the next step, insert new record with updated city and previous city, what you captured in the temp table. So these 4 you captured, 5 you captured. Along with that you need a start date as a current date and end date, maximum date, and as a active record. That's what you are making hard code these values. It's okay. That is what. Now if I run this script, you are inserting into main dimension table, so that now 3 records are there in this table. So 4th record is going to come for the same customer ID 1. I am running this. Now you can see that. So have a look mainly in the dimension table, the 4th record. What happened? Have a look, this record. This Hyderabad came here. That is because of the previous step. You captured that value actually, and all other stuff have observation. And this is the active record. One way you are capturing the entire history for this column. That's what we discussed for type 6. So history you are maintaining for few columns, and at the same time in the current active record the previous value of for that attribute also you are maintaining. So for so and so attribute, the dimensions you are maintaining as a history and the immediate previous value also you are maintaining in the current active record. So that's what we discussed here. Type 1, 2, 3. Type 3 talking what actually? Immediate previous value is what? That's what you are maintaining. So simply here we are maintaining. So overall nothing. And now one more step is here. Here if you observe in the staging there is a new record. So new records how you can do? Just you see that also logically there is an interesting one. Have a look. So of course you are inserting into the main dimension table new record. From where actually? From the staging table. That's what, right? From staging. Have a look. The from clause is staging. But the thing is, the records, this is actually correlated subquery you can call. Okay? Correlated subquery means subqueries are different. Correlated subqueries are different. You written in the query, main script is here select. I am just giving brief now. So this is the main select statement. In that, either in the select clause you can write down the subqueries, or in the from clause you can write down the subqueries, or in the where clause you can write down the subqueries. So there are different places. Especially when you are writing in the where clause and you see the reference yes, the alias name for staging is yes, and here you are referring the table dimension table D. In the subquery, if you referring the outer query's alias name, this query is not independently going to run. This is always correlated with the outer query actually, because you are referring yes, right? So you are coming to here again. So into outer to inner, then inner to outer. So both the select queries are dependent actually. So if there is a query like this, for example, select star from EMPE where DEPT number equal to select star select DEPT, or I'm just writing randomly something, not randomly, meaningfully, but DEPT number from DEPT table D. But this is also a subquery. Inner subquery is this one. This is inner subquery. This inner subquery nowhere related to the outer query actually. So it is independently going to select the minimum value, then that result is going to replace in this RHS of the condition. Then once that result, suppose minimum value is 10, that is going to execute independently the outer query. That is what normal subqueries, independent, but this is dependent because you are referring outer query is one of the table. That's what correlated subquery. That's why most of the cases exist will come actually, exist or not exist. What is happening actually? So here what you are telling actually, you are taking one record and you see here you can observe simply if you want more elaborated discussion quickly. So here the staging table let us try to take, not need now this temp table, it's done. So here the 4 should not exist in this actually. How you will identify this is a new record, that is the main thing here. So 4 is not exist out of all this, that's all. So you are taking just 1. So what you are doing here is customer ID from here, customer ID from here. If you select 1 1, what is going to happen? Just observe 1 1. That means match is occurred, condition is true. So if you go little up, that means here match is occurred, condition true. Inner query I am talking, match is occurred. That means 1 is going to replace in this whole place. 1 is going to place. When 1 is there, that means it is true. But you are telling not exist, nothing should come here. That means not exist, false should come. So when it is not exist, but inside something is exist, that means overall condition is false. So for this record, not going to consider. Then the next record for 2, yes, 2 is exist, 2 equal to 2. So condition true inside, that means 1 will come. So something is existed, something existed, but you are telling not exist. Only when not exist you have to consider. So false for this record also, false for this record also. Now come here for 4. D dot customer ID, here there is no 4. That means 1 is not going to come in the inside. Nothing is there. That means nothing is there. Yes, not exist inside. So not exist or not, when I ask, what you will tell him? Something is not there inside. That means yes, it is true, not is there. Nothing is there inside. So overall condition is true. For whom? For the 4th record. That means what actually? This is a new record, that's all. That new record he has to insert with the previous value as null. Have a look. Previous value as a null, and the current date as a start date as a get date, end date a maximum, active record because it is a new one. So that you are inserting into dimension table. If I run this script now, what you are going to observe, this Priya Singh is also as a fifth record in this main dimension table. Just run this, observe the changes. So have a look. Master all these concepts, very important. See, the fifth record Priya Singh came as an active record. So overall in the type 6, it is really very interesting what we have done. That's what we learned till now. Okay, so for the existing active record, do the updates, but while doing update, capture the existing values and current city as a previous city, you capture it into the temp table. So temp table is also involved here, and then the temp table data you simply insert into this main dimension table. Not only that, you should take care of new data. So for the new data also, you can put a relation, identify the new records actually. So that is what simply type 6, the script implementation wise. Okay. So that's all the what is happening, the key points in this type 1. Okay, type 1, you are getting the current value directly by taking the city column. Type 2, you under the same city column, if you take the entire history actually, and type 3, that by using another column in the same active record, you can get back the previous value, just immediate previous value. That's what actually overall this SCD types 6, that's what overall the SCD types 1 to 6. So if you simply summarize overall discussion, this is what SCD types, okay, and keeps history. No, you can just call back what we discussed till now actually by using this entire comparison table. So one small thing I would like to request you, if you are not yet subscribed, please try to subscribe and please like the video and please give the positive feedback. Thank you.